So a median is a line that goes from a vertex to the midpoint on the opposite side. Okay, and I will draw a picture to demonstrate. All right, so if I draw any old triangle, okay, the top point here, remember this is a vertex. All the corners of your triangles are called vertices. Okay, if I make this my midpoint, tick, tick, okay, and so that means that my median goes from vertex to midpoint. Okay, that's what a median looks like. The centroid is the point of concurrency for the three medians. It's where the three medians intersect. And you see a picture right here. Okay? BE in this picture below that I circled is a median, FC is a median, AD is a median, G is the centroid. It's where the three lines intersect. Okay? Okay? It's just a neat little exercise to show you where the centroid was. Okay? So you should have ended up with a picture that looked like this. Biggest mistake that people made was they had their lines going here, straight up, okay, not through a vertex like B is. Okay, and that's why they had trouble. Okay, they were doing the perpendicular bisectors rather than the medians. All right, so concept for the centroid. What you have to understand, if G is the centroid, it is 2/3 the distance from the vertex to the midpoint, tick, tick. Which means from the centroid to the opposite side is 1/3 the distance. What's 2/3 plus 1/3? 3/3 or 1. Okay? So our fill in the blank part, the centroid is 2/3 the distance from the vertex to the opposite side. Okay? All right, so what we're going to do is I'm going to go through a bunch of examples with this. Okay, you can write down like maybe the first one, and then after that I would just look up here and see if you can figure out the numbers. Okay, all right, so in order to help with this, how would you compare 2/3 to 1/3? What's the relationship between the two?
Oh, one is half of the other one.
So 1/3 is half of 2/3, and 2/3 is double 1/3. All right, so if I said that from A to G was 6, can anybody tell me what G to D is?
3.
Because since the 1/3 part is half of the 2/3 part. Okay? What's the entire length from A to D? 9. So let's try this. Is 2/3 of the whole length 9 equal to 6?
Heck yeah.
Yes.
Okay? Is 1/3 of 9 equal to 3?
Yes.
Okay? Because 1/3 is the same thing as dividing by 3. 9 divided by 3 is 3. So it worked. Okay? All right, so now I'm going to erase this, and I'm going to start all over. Okay? And I'm going to use new numbers. This time I'm going to start with the 1/3 part. If I said that, say, this was 8, what's A to G?
16.
Because 2/3 is double 1/3, it's 16. What's the whole thing? 24. So here's your check. Is 1/3 of 24 equal to 8?
Yes.
So if you can take 24 and divide by 3 and get the little piece, you did it right. Okay? All right? Starting again. This time, I'm going to give you the length of the entire segment. So from A to D, is equal to 30.
10 and 20.
What is the little piece?
10.
How'd you get that?
'Cause
1/3 of 30.
1/3 of 30, or 30 divided by 3 is 10. Okay, and then this is 20. And you can do either 2/3 of 30 or 30 minus 10. Okay, so notice 10 doubled is 20, half of 20 is 10. Together they add up to 30, so it's all working. Okay? Questions so far? This is the big concept that we need to understand from this section. Okay? All right, so here, they gave us that DG, this little piece, is equal to 3. What's AG? 6. What's the whole thing AD? 9. So remember, 1/3 of 9 gives us the 3. 2/3 of 9 gives us the 6. Okay? All right, and then 3 plus 6 gives us the whole thing. All right, so try example number 1. Do all 3 of the triangles. See what you get. What'd you get for A? For RP.
For RP?
Yep.
I got 16.
Okay? And what'd you get for PT? 8. Because 24 divided by 3 gives me 8. Double it and I get 16. The 2 added together equal 24. Sammy, what'd you get for B? Okay, so let's do this together. If RP is equal to 10, what's the relationship to PT? How do you get it?
It's 5.
Divide by, all right, so what's 10 divided by 2?
5.
I'm not asking you. What is it? All right, so 5. Okay, what's 5 plus 10? There you go. And remember, your check is 15 divided by 3 should equal 5. Okay, you're running C. Okay, and RT equals?
21.
Very good. Okay, any problems there? Okay, so on the next one, we're just going to apply it to algebra. Okay, so on this one, they tell us that GC is equal to 4x plus 5. They tell us the whole thing is 9x. We have to solve for x. Any ideas?
No.
I don't know.
Nice.
Anybody?
All right, sure.
Go ahead. You sure? Summer?
I don't know if it's right or no, but I'll try it. So what if we said equal to, and then for the left side, like the smaller side, we can just divide the number, whatever we get, divided by 2.
Okay,
Can we do it that way?
you could. What's the purpose? What would you do with that?
Maybe we can find the other side, the FG.
Okay, so he says that this little piece FG is this divided by 2. Do you agree with that?
Yeah.
That it's half? Well, that's what you just did on the other paper, so he should be yes. Okay, so he divided this by 2, and hopefully you get 2x plus 2.5. Okay, and then what do you do with those 2 pieces of information?
Instead of equal to 9x.
Add them up and set them equal to
9x.
9x. Now, Colin had another way.
6x equals 4x plus 5.
Okay, so you're going to have to explain where the 6x comes from.
It's 2/3 of 9x.
2/3 of the whole thing, 9x, is equal to this medium-sized piece of 4x plus 5. So he used the fill-in-the-blank theorem that we talked about on the previous paper. Okay, and so that's why he has 6x equal to 4x plus 5. Now you can solve for x. Now Summer is correct. You could do 2x plus 2.5 plus 4x plus 5 equals 9x. Either way, you're going to get x equal to?
2.5.
X is going to equal a 2.5. Questions on that? So you have to understand the relationship between the two. Okay, so on the homework, they're gonna do something like this, okay? They're gonna say blank GC equals FC, blank FC, like that. Well, would you agree that 2/3 of FC equals GC? All right, and then that's what you would do. You would fill in the 2/3 in order to make the two equal to each other. So we did 2/3 of FC is equal to GC, and that's how we set it up, okay? Or, like Summer said, you can find the missing piece and then go from there, okay? All right, scroll down to the bottom. We're gonna skip the graphing one for now, okay? All right, there's not much to understand for altitudes. There's no real properties. The only property that we talked about already, and that was in chapter 1, is it is used to find the area of a triangle. So first thing you need to understand is the altitude has the synonym that it is the height of the triangle. Reminder that it goes from vertex to opposite side and forms a right angle. Okay, so a picture to go with that. If I had any old triangle, here's my vertex, I drop it, and I get a right angle. That's what my altitude is going to look like. There are 3 of them. Since there's 3 vertices, I can draw an altitude from all 3 of the vertices. Okay, my orthocenter is the point of concurrency for all 3 altitudes.